In this video, we will discuss the mean. A single number that is in some sense representative of a whole set of numbers as a sort of middle value is called a measure of central tendency. The most common measure of central tendency is the mean, or arithmetic mean. The mean of a sample is denoted x bar, while the mean of a population is represented by the Greek letter mu. The mean of a set of data items is found by adding up all the items and then dividing by the sum by the number of items. Adding up numbers, or summing, is a common procedure in statistics. We use the symbol for summation, sigma. The sum of n items can be denoted sigma x equals x1 plus x2 plus x3 plus so on and so forth up to xn. The mean of n items, x1, x2, and so on up to xn, is calculated as x bar equals the sum of x over n. Here's an example. Last year's annual sales in dollars for 8 different online businesses were as follows. And here are those numbers: 374,910, 321,872, and so on. Find the mean annual sales for the 8 businesses. So the solution is that x bar, the mean, is sigma x divided by n. Well, the sum of all of those numbers is 2,682,712. We divide that by 8 to get 335,339. So the mean annual sales amount is $335,339. A weighted mean is a mean for which the values are multiplied by some factor, because different values have different importance to the overall score. The factors are called weighting factors. Grade point averages are an example of weighted means. The grades are weighted by the number of units or credit hours per class. Your standard English class might be worth 3 hours. A science class that includes a lab might be worth 4 or 5, while something like a sport or choir could be worth only 1. So one semester's grades might look like this. For math, you've got an A, because we all know you're getting A's in math, with 3 units. History is, you got a C there. Again, that's 3 units. Physics, you got a B, 5 units. Art, you got a B, 2, that's 2 units. And phys ed, you got another A, that's 1 unit. The units here are the weighting factors. We calculate the GPA by multiplying the grades by the units, adding the products, and dividing by the sum of the units. So the grade point average here is 4 times 3 plus 2 times 3 plus 3 times 5 plus 3 times 2 plus 4 times 1 divided by 3 plus 3 plus 5 plus 2 plus 1. So that's 12 plus 6 plus 15 plus 6 plus 4 over 14. Which is 43 over 14, which is about a GPA of 3.07. The weighted mean of n numbers, x1 through xn, that are weighted by the respective factors, f1 through fn, is calculated w bar equals the sum of x times f over the sum of f. The weighted mean of a group of weighted items is the sum of all products of items times weighting factors divided by the sum of the weighting factors. So for example, the frequency distribution below shows the salary and number of employees who receive that salary for a small company. Find the mean salary. So here we have salaries of $12,000, $16,000, $18,500, and so on. And the number of employees, the frequency, so 8, 11, 14, and so on. So we set up the work by adding a column and a row to the frequency distribution. The column will give us the salary times the number, and the totals will be the row. We have a total of 45 employees, and a total salary times basically the total amount that we're paying out for salaries is $838,000. So the mean salary will be the sum of the salary times the number divided by the sum of the numbers. So that's $838,000 divided by 45. It's about 18.622, perhaps even exactly 18.622. It's not exact. For some data sets, though, mean can be a misleading indicator of average. Consider a company for which the workers have the salaries 16,500, 16,950, 17,800, 19,750, and $20,000. The mean of these salaries is $18,200. But the CEO has a salary of $188,000. And if we add that to the mean calculation, suddenly the mean salary jumps up to $46,500. That extreme value of $188,000 is called an outlier. A single outlier can have a significant effect on the mean of a data set. So we say the mean is highly sensitive to outliers.